So up to this point, we have found the relationships between angles and arcs in circles, right? There's relationships there. If the angles are outside, if the angles are inside the circle, and the arcs, inscribed angles, central angles, subtended arcs, intercepting angles. We've looked at all those things. The last section we just covered, we saw that there is a relationship between the segments of secant lines and tangent lines, as well as chords when they cross each other, inside of circles and outside of circles. The only thing we haven't done yet is figure out how to actually graph a circle. So how can we plot a circle in the coordinate plane? It's the thing we don't have yet. So in order to figure this out, I need you to think about what do we need, basic stuff do you need in order to make a circle? What two things do you need? There's two things you need to make a circle. Think of the definition of a circle. What is the definition of a circle? Take your time. What's the definition of a circle?
No curves. No points.
A round shape with no curves?
No lines. No lines.
Vertices.
No lines? Okay, but I can make all kinds of shapes with that definition. What makes it a shape that's so perfectly uniform all the way around?
Arcs.
What's going on with these points? What's so unique about all these points of a circle? They're equidistant from? So you're telling me that I need to have a center in order to talk about a circle. And then that equidistance, what do we call that equidistance on a circle? It's a radius. So in order to come up with a circle, you got to give me a radius and you need to give me a center, correct? So we need a radius and a center. So in the coordinate plane, here's the problem. We don't talk about radiuses and centers normally. We talk about x and y, right? We talk about distances. Well, radius is a distance, correct? So we can plot a center point. Let's plot a center point. Mine's going to be not on the origin right now. So this is going to be my center point. I want you to call this center point H, comma, K. These letters are going to represent my coordinates for my center. Okay, so if you wish, you can do this on your grid. I personally will not be drawing on the grid because it's too hard for you to see whenever I draw directly on this. You can do it fine, but whenever I draw, it doesn't show up well on the projector. So I'm going to do my work right here where you can see it. Okay. So H, comma, K are going to represent, those letters are now going to represent for us generalized coordinates, right? Any set of coordinates in the plane. Now you told me the other thing we needed was a radius, correct? Okay, a radius is a certain distance out from my circle. And then all the points are going to be that same distance out all the way around. Is that correct? Okay. So there's my halfway decent circle. Now, here's what I want to point out to you. If I chose just any old point on this circle, I'm going to choose this point right here. In order to describe that point, I have to describe it using x's and y's. I need to describe it using an x coordinate and a y coordinate, correct? So we're going to use the distance formula to talk about this. Absolutely. This is going to be the distance formula. Or more to the point, the distance formula is really what in disguise? It's the Pythagorean theorem. So in order to come up with this circle, we're actually going to use right triangles to make our circle. Like, whoa, Mr. Duncan, the right triangles are pointing. Circles are not pointing. I don't think this is going to work. It will. And here's why. Because the right triangle is going to help us maintain that radius, right? Because we know that x squared plus y squared equals r squared for us, right? So our equation for this circle is actually going to be this distance here, so I'll put that in parentheses for now, squared, plus the distance in y squared, and that should equal our radius squared. So that should be our equation. The trouble is we now need to figure out what those distances are. Well, here's what I know. This distance has an absolute value in terms of reference to the x-coordinate, right? That's an x length right here. But that doesn't represent the entire x length, correct? We don't need the entire thing. We need to subtract off however far away the center is from our axis, right? So this distance here is actually going to be x, but then subtract off h. Does that make sense? This distance here is going to be x minus our center distance. So this will be x minus h. Similarly, we don't need this y-coordinate right here. That's not our actual distance, the actual length here. That length is y minus the height of our center, which is k units. So this is going to be y minus k. And that equation, my young friends, is the standard equation of a circle. That's the equation we are going to write in this box up here. So this first piece is just the distance in the x direction, which means this is the distance in the y direction. And lastly, this is going to represent our hypotenuse. So we're going to use right triangles to build our circle. And if you want to be clever, which I think you can be, I'm going to highlight each piece. I better not use yellow this time, though. That won't work out so well. Yep. Yep. Oh, that should be blue. It turned green. Oh, that's clever. Why did it turn green, guys? Because, yeah, I put a blue marker on yellow paper, so it makes green. That's fantastic. Yeah, that I got. So I guess what I'll do to make up for that is I'll take a green marker and there we go. Haha. And this is going to be pink, not like the singer.
Is this singer?
Yeah. All right, so this is going to be the equation of a circle, folks. You're like, this is kind of different. I realize this is possibly the first time you've ever seen the equation of a circle, especially in a math classroom. So this is your first exposure to it. It's going to feel a bit strange at first because we're not used to seeing two terms being squared. And we're used to seeing the x on one side and the y on the other. Now, remember the warm-up we did this earlier today?
Yes.
Where we talked about completing the square? This is where it shows up. This is where it's going to start showing up. Okay, so that's coming later. That's going to come in about 5-10 minutes. I want to test this theory out, though. I want to come up with an equation for a circle, and then I want to graph it and see what it looks like when I graph it. So if I'm going to move this over to where it rightfully belongs, over here. So there it is. And now let's see if we can do the thing that they're asking for here. This says they want us to write the equation of a circle, and they tell us that the center is at the origin, so my h and my k is going to be what?
0, 0.
Very good. So we're just doing straight up substitution. Would you please substitute that in? So I get x minus 0 squared plus the quantity y minus 0 squared equals the square root of 10, all of that squared. Now, this is not currently simplified. We need to clean this up still. What's x minus 0 really? It's just x, right? So we're going to write this just as x squared. So if you don't see anything in the parentheses, you know that your center is at the origin. And the square root of 10 squared is just 10. So that is my equation. Now I have some good news and some bad news. The bad news is that this is hard to graph in your graphing calculator. In order to graph this, we'd have to solve for y. So you'd have to subtract x squared to the other side, and then you'd have to take the square root of both sides, correct? Okay, try that out on your calculator. So let's see what this looks like. And I will write it down just so you can have a visual of what you would have to write down. So moving that over, I would get y squared equals 10 minus x squared. Just move the x squared over by subtracting it, right? And then to solve for y, I have to take the square root of both sides. So I'll end up with y equals the square root of 10 minus x squared. Would you please type that into your calculator and graph it for me? Tell me what you get. Okay, you got it graphed?
Mine doesn't curve.
So that's what I get. Hey, Paula. So it doesn't look like a circle, does it?
Mine didn't.
And the reason being is because you actually have to tell it to zoom in so that your axes are square. So you go to zoom. And there should be one that says zoom square, I think. It's like number 5. And then when you graph it, it's going to look more circular. But the same problem, though. What's the issue here? It's not a full circle. It's only a... It's only the positive y values. Because our equation here says y is equal to the square root. Well, that's the positive square root. Everything underneath the square root has to come out as a positive number or 0, correct? You can't we don't have square roots of negatives here. Next year you'll be dealing with that. So when you say y squared equals this value, you actually have to say that y squared, whenever you take the square root, becomes this. Y is equal to plus or minus the square root of 10 minus x squared. Problem is, your calculator does not have a button for plus and minus in it. Because your calculators are kind of based on 90s technology. Like, these are the same types of technology that I had when I was your age, literally. It's that old. They've added a few features here and there. So you have to actually type this equation in twice. One is a positive, and then the other you have to put a negative in. And that'll give you the bottom piece. Okay? So that's no fun, right? Just type it twice. Thankfully, we have new technology now, so I don't have to use TIs anymore. And maybe if I can convince the district, maybe they'll listen. I don't know. But other districts are actually using new technology that's free. So Desmos is free. It's on your it's on your phone if you want to install it as an app. You can type the equation in exactly as it looks right here. X squared plus y squared equals 10. Let's see what happens if I do that. X squared plus y squared equals 10. Well, there it is. And let's plot this thing. There it is. Okay, and I'll zoom in a bit. And it looks like we're centered at 0, 0, and the radius is approximately 1, 2, a little bit bigger than 3, which makes sense because the square root of 10 is like 3 point something?
3.16.
Yeah, okay, so it makes sense. This is a little bit bigger than 3. All right, so far so good? So this is definitely graphing the thing that we wanted to graph. Now here's my question. If I wanted to shift this over 2 units, what would this new equation be? So I'm going to peel this off because I don't need it anymore. And the screen's going to go dark either way. Just deal with it. So if I wanted this equation shifted over 2 units to the left, what would this become instead of 0?
-2.
Right, so moving to the left, I would get x minus -2 squared plus y, and if I want to move 1 up, it'd be y minus just 1, positive 1. And my radius hasn't changed, so it's still going to be just 10. We'll just leave it as 10. We know that's going to be 10 after we square the square root of 10. So this part of my equation is still not cleaned up. X minus a negative is the same as x plus a positive. So I could rewrite this as x plus 2 squared, and then the other part, everything else is good to go. So this has got a new center, And the center is now, instead of being at 0, 0, is now at negative 2, comma 1. I moved 2 units to the left and 1 unit up. Let's see if I graph this right next door, and let's see what happens. So let's pull it up, and let's shrink you down a bit so we can see everything. And the new equation, let's see if we can type it in. X, come on now, x plus 2, got it? Close parentheses, squared, plus, open parentheses, y, minus 1, parentheses, squared, equals 10. Hey, what do you see? Yeah, they're crossing because, oh no, I stretched it, oh no, square grid, don't stretch, don't smush them, there we go. Okay, pull that way, there we go. So let's see. It seems that this circle, the center looks like we are right about there. So let's see, how far over do we go? 2 units over and 1 unit up. So this is doing exactly what we're asking it to do. It's behaving the way we would expect it to behave. Guys, how's it sitting with you? It's going to take a day or two, yeah, before this sinks in properly. Some practice, right? Good news. I have left a problem for you to do. 1B. Off you go.
Oh, I thought that was the one where
Yes. Okay.